Hi folks, it's Digital, a hunting gear guy. I was looking around on eBay for one of these BRS3000ts. Apparently, the better place to buy one of these is off AliExpress. They're a titanium, very lightweight stove. They're liked for how lightweight they are. I found they don't really cook that well in wind, but on eBay I also saw a whole bunch of knockoffs of this, if you can believe it, because it is just a Chinese stove. But I also found these bronze style ones, bronze, brass, whatever, it's yellow. And they've got a different style burner on there, different style supports. And then I found another one that said it was a BRS, and I was like, oh, well, I just got to get all of these and test them all out together. So that's exactly what I'm going to do. I have finished doing a battery of tests to these and some measurements and weights. So why don't we start into that? Now let's talk about the real BRS for a little bit, just to start with. There's a couple of things that are kind of interesting with it. First, it's very light. Like 25 grams is super duper light. It's got quite flimsy pot supports on there. There's not really much to them, and you really do want to make sure that you've got the pressure coming down straight on them. Some people have said if they put like a big pot on here and they get it really cooking, a really big flame out of it, these supports can actually get hot enough where they start to soften, and you'll have the pot fall off of here. The other thing that I found is the base can heat up pretty good because it is a pretty short stove altogether. So there's a little bit of air coming in through here, but not enough to cool it to where it won't stop that heat soak that goes down in here. Could be a good thing. I mean, you might want that heat to get into your canister. Personally, I think that might be what is causing some of the failures of the O-rings in here, because they do let so much heat down into this body, and if that gets onto that O-ring, maybe it degrades it a bit. I don't know. In terms of the measurements on it, the pot to burner, so the difference between the burner and the pot there is 1.9 centimeters. So it stays actually pretty close to the pot, and that's good for windy conditions. And I'll show you some of the results of that shortly here. The base to pot, so the compactness of it, is also very good. So 6.4 centimeters, so it's a very compact stove. It stays nice and low to the ground. And then finally, the support diameter of what it can support, right at the tippy tips of the supports, is 25 centimeters. 25 centimeters around is what it'll fit. Now the brass BRS, it has quite a bit of a shorter control arm on it. It doesn't feel quite as nice as the BRS, but it's okay. The thing that is, there's two things that are really kind of crappy about this one. One is that it soaks a lot of heat into the base on this thing. I got a measurement of 130 degrees Celsius on the base here. It was like boiling water if you touched it on the base here. So it gets very hot. It's got very small air holes in here, so there's not really a lot of cooling air coming up. And the other thing that you'll notice is that the flame that comes out of this thing is very yellow, and it puts a lot of soot into the bottom of the whatever you're cooking. So you really need to run this thing at almost like full blast, or at very high volume, so that you get mostly blue flame out of it. If you start to choke it down, it starts to yellow out, and you start to get lots of carbon and soot all over. And you can see a little bit of that soot here. That's actually burned off a little bit when I was running a little bit hotter. But if you try to dial this down and run it at a slow boil, that will cause a lot of carbon out of the flame. Now, in terms of measurement, this one's a little bit higher off of the burner. So our burner to pot is 2.4 centimeters. Our base to pot is quite a bit taller. That's 6.9. And our support diameter, it's a little bit wider, and we could support a pot that's 29 centimeters in circumference on those supports. Finally, we get this aluminum one. Now, there are some things I kind of like about this one. The flame on it's very interesting. It's almost like a candle. It's a jet right in the middle there, which could be good if you're just boiling water. Terrible if you're trying to cook anything and not burn it right in the middle. The things that I really liked about this one, again, was just that flame pattern. The regulator on this thing is so stiff. It feels like I'm going to break that wire. It's just super stiff in there, and that's how they all. Actually, I accidentally ordered two of these things, and the other one had a super stiff adjustment on there as well. The other issue with this one was that because it's so tall, because the burner to pot distance is so large there, any amount of wind really hurts the boiling performance of this of the flame on this one. So that was also interesting. This is also a very tall stove. So our our burner to pot is 2.5 centimeters. Our base to pot height is 7.8, so we're almost a centimeter taller than the other burners the other BRS 3000s that we've looked at. And our support diameter is 30 centimeters, so that's a little bit wider on this as well. Now let's talk about performance of these stoves. Now the thing I tried to do was to boil 2 cups of water uh, in the most efficient way possible. And the way I was judging efficiency is I was looking at the bottom of the pot and I was trying to make sure that the flames were not spilling out the edges and going everywhere, but that we're getting a good consistent burn that would hopefully bring us up to boil without wasting too much fuel. And I think I did it with all of these stoves because they all boiled in 7 grams. So they all needed about 7 grams of fuel, not about, they all need exactly 7 grams of fuel measured on a scale to boil those 2 cups of water. And the stats I had was it was 5 degrees Celsius ambient and it stayed that temperature. The water was 17 degrees Celsius, so it was a little bit warmer. That's just what it came out of the tap as. And I measured in between boils to make sure that it stayed the same. And we boiled 2 cups of water, 500 milliliters. Now, where the differences came was with a little bit of wind. And I say a little bit of wind because I did not have like a gale force going on these things. I had maybe 2 kilometers an hour. It was so low that I couldn't actually measure it effectively with my my wind meter, anemometer. Anemometer? Anemometer? I don't know. The wind meter, anyways. I actually had to measure the wind a little bit further away from it to get a proper reading of like 5 kilometers an hour, and I guesstimated that at the stove it was right around 2 kilometers, maybe, so like a very light breeze, but it impacted the performance on these things so much. So the real BRS, when you put a wind speed of 2 kilometers on it, I couldn't get it to boil. I couldn't get it to boil at all. I used 18 grams of fuel, and it was like right at boil for a long time. Just never got it to a rolling boil. So that says something. Now, if you were to ask me why, I personally I think that the gills on the burner might trap air in there and get it in there and move it over, because it did move the flame quite a bit, and with that wind on there, you could put your hand about here and feel no heat at all. It was all just moving away from the burner. So really, when you want to get better performance on a pot, what you really need is something that keeps the burner very, very close to the pot, as close as possible, and that's where you get better efficiency. So we tested a couple of other styles of stoves, and those ones all gave better performance because they kept the burner so much closer to the pot. So, long story short, efficient in ideal circumstances, fantastic, especially for the weight. With some wind, awful, just terrible. Now, the other thing that we did, me and my buddy of mine, we actually tested this thing out in -15 weather. So out in -15 with the canister sitting out there for about an hour, we went out and we lit it up, and it ran. We did all season blend of fuel, and this guy, it ran, and with no wind speed in -15, we got to a boil. We got to a boil actually fairly easily. Considering we just finished these wind tests. So it will boil water in some pretty crappy conditions, but you can't have any wind on this thing or it just will ruin the performance. Now the next one was our bronze BRS, and same thing, 7 grams in ideal conditions. We dialed it down so that there was just a nice flame that just barely got to the edges of the pot. A lot of yellow flame, and it made a mess of the bottom of the pot. You will carbon the heck out of the bottom of your pot if you run it at those reduced volumes. With wind, this guy took quite a bit more. It took 14 grams, and the thing is, the really worrying thing, with the wind on there, 2 kilometers an hour, not a lot of wind, the base on this thing got up to 130 degrees Celsius, so really cooking. I don't really know what that'll do if you get that kind of heat into the can. It's probably fine, but it's probably not really designed for that kind of thing. It's probably not designed to have like that amount of heat right at that junction there. So it's probably not good for the can, and it was a little bit troubling to me. Finally, the tall BRS. This one performed a little bit worse than that bronze one because it's got that height there. But we still managed to get it to boil. It took about 16 grams of fuel, and it boiled in 13 minutes and 40 seconds. So still did it, just not as efficiently as in ideal circumstances. And I think that's partially because, well, you can take a look at the video, but even with a little bit of wind, because it's got such a centralized flame there, even moving it just a little bit over, it's still going to hit the pot. Now, the thing is, the reason why we didn't move the pot around on the supports was what happens if you get swirling wind? Yeah, you could move your pot over if you've got a consistent 2 km/h wind pushing the flame over. You could move the pot over a little bit, and you could get a more efficient boil on it. But what if the wind is moving in your tent? Well, you can't. It just has to perform. So that's why we chose to just leave the pot centered on there and see how they performed with a little bit of wind, 1-2 km/h, not a lot. And if it was swirling in there, the wind, I mean, you would want to know how your stove is doing or how poorly it's doing. So overall, which of these stoves would I recommend? Not this guy, just the heat that it puts down, the flame quality on it is just awful, and the weight is just not that good either. So that brings us to the genuine BRS and this aluminum doohickey here. This guy, in ideal circumstances, I really liked it. It is heavier and bulkier, but it's got a nice consistent flame on it, and it doesn't heat up the base at all compared to the BRS. So there could be some pros and cons in there. I think really all of these stoves are kind of fair weather stoves, and if I've got to get a fair weather stove, it might be one of these guys, just because it's still more expensive than those other two. This was about twice the price of the knockoff BRSs. But the weight savings on it would be really nice. And in ideal, like if you start getting a little bit of wind in there, put a windbreak or something like that, so that this thing can perform as it should.